Hi, folks. Welcome to 1 Minute Math today, where we're looking at the extended cut of SOH, a more thorough explanation of how to use right triangle trigonometry to find a missing side of a right triangle. So what that means is I'm going to be looking at a right triangle here, and I will know one angle about it. So let's say this is 40 degrees and one side, and I'm going to be looking for one missing side. This is slightly different than the Pythagorean theorem. In the Pythagorean theorem problems, we're looking still at right triangles. You're usually given two of the sides, and you have to find another. So in this case, instead of having two sides, we've got a side and an angle. And, like we put a man on the moon, knowing a side and an angle, we ought to be able to find one of the other missing sides. And indeed we can. And it's this great tool called trigonometry that was given to us from the Greeks. Tri, three, gon, polygon, metri, measure. So this is really the measure of triangles is what this topic is called. Okay, so trigonometry or SOHCAHTOA. The word SOHCAHTOA is really just a fancy acronym to help us remember SO, CA, and TOA, sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite, adjacent. That refers to the fact that given any right triangle, and given a perspective, well, given any right triangle, I can identify one side as being the hypotenuse. The hypotenuse is always the side opposite the right angle. It is the longest side of a right triangle. We don't use the word hypotenuse just to mean the longest side of anything. Sometimes people misuse it that way. But if I say hypotenuse, it means I'm looking at a right triangle and I'm referring to the longest side of that right triangle, which is indeed across from the right angle. Now, given any other angle in that triangle, let's say I say this is my angle up here, that's going to be like my perspective or my main angle that I'm interested in, I could refer to these other two sides. I can give them names that represent their position with respect to that angle. This side way over here that is not touching that one at all is rightly called the opposite, because it's opposite of the angle. It's not touching it. And then in math, instead of saying touching or next to, we use the word adjacent. So this side here, this guy, we're going to call him A for adjacent. You might be thinking, well, the hypotenuse was touching it too. Yes, the hypotenuse is an adjacent side. But since hypotenuse already has a name, we're going to use the word adjacent to only refer to the non-hypotenuse side of a right triangle that is touching the angle we're looking at. And we can use that OAH designation regardless of what my triangle looks like. Maybe I'm looking at, this is my angle, okay? I would say this side's the hypotenuse because it's the longest side. This guy over here now is opposite. This one is adjacent because it's touching. It has nothing to do with which side is longer, which one is on the right, which one is on the left, which one is above or below. It's all about in regard to, like with respect to where you're looking, which angle is identified as your angle, which side is not touching it, which side is touching it. And then the hypotenuse, the longest side. So then the Greeks gave us these fancy words, sine, cosine, and tangent. Each one of them represents a fraction, and that fraction is the ratio of any two sides. So for instance, when I say sine, I'm talking about the fraction that represents the side opposite divided by the hypotenuse, okay? And that might seem like a really silly, might kind of seem like a nonsense way to define these fractions, but you have to remember this came from ancient Greece, so it's not going to sound kind of usual to us because this did not come out of our time and place. Anyway, let's go ahead and look at an example. So how I would use this ridiculous SOHCAHTOA thing to try and find a missing angle in a triangle. I'm going to look at this picture of this triangle right here, and you'll notice that one angle has been identified, this one with the 25 degrees on it. That's marked as like our angle that we care about, our angle of importance. And I'm going to start by identifying the sides of my triangle with respect to that guy. 41 here is going to be the H because it's opposite the right angle. It's the longest side. Then this thing that we're calling X way over here, he is not touching that 25 at all, so he is opposite. And then by default, this side down here is the adjacent. And now I'm going to notice that 41, that was important to me. That was a number. That's part of my problem. So H I care about. The X was part of my problem, so I care about O. But there was nothing down here. No variable, no number. So I don't really care about A. The only sides that are interesting to me in this problem are the O and the H. And I go back to my funny word and say, which one of these things had an O and an H? And it's sine. So sine is like the first name of where I'm going to look for. When we look up sine, cosine, and tangent of numbers in our calculator, we're basically like paging through a catalog or like a phone book, a directory that has all of these numbers in it, all these ratios of different sides. And the sine, cosine, or tangent is like telling us what is the first thing we're going to look for in that directory. All right, so sine. And if I just type on my calculator, hopefully you have a calculator handy, and it's got to have a calculator that says sine, cosine, and tangent on it, have those buttons. If I just type in sine and hit enter, it blows up at me. I have to tell it what angle I'm interested in. So I'm going to type in sine 25. 25, and it is 0.423. And then I'm also going to think about this fraction. So sine equals opposite divided by hypotenuse. So this sine, this 0.423, was also equal to the opposite, which is x, divided by the hypotenuse, which is 41. Both of those things represent the sine of 25 degrees. This gives me an equation that I can solve for x. If your algebra skills are solid, you might look at this and say, oh, I can just multiply both sides by 41. Great, do it. If you're feeling a little bit more uneasy about the algebra here, just put the decimal over 1, and now you have a cross multiplication situation. Hopefully you've done a bunch of these kinds of problems at some point in your life in a math class where you know like a times d equals c times b and cross multiply your fractions. If I do that here, x times 1 equals 0.423 times 41. Oops. Which is 17.327. I'm going to write it out for you. 0.423 times 41, or x equals 17.327. Bam, look at that. We just solved for x. Woohoo! Let's try one more example together. I could try a bunch of examples here. I think I'm going to skip that one for now. Let's try this guy. This one's going to illustrate a couple of things for us. All right, so there's my angle. This side up here is my hypotenuse. He's the longest one. That one's opposite. This side is adjacent because it's touching. Right away, I notice I don't care about the h. There's no number. There's no variable up there. 15 and x are O and A. O and A. Nope. O and A. Nope. Tangent. TOA. So tangent is my function that I care about here. Tangent of 20 degrees. Type that in my calculator. That is 0.364. And the fraction here is going to be O over A, 15 over X. So the second thing I'm illustrating here, the first thing I was illustrating is just getting a different trig function. So it's not always sine. Whether it's sine, cosine, or tangent really does depend on what pair of sides you have. You can't skip that step where you're looking at like what's O, what's A, what's H. But now I notice when I divide this by 1, I set up my proportion, I can't just multiply both sides by 15. The algebra here is a little bit more complicated. If I cross multiply, I get 15 times 1, which is 15, equals 0.364 times x. So to get x alone, I now have to divide by 0.364. 15 divided by 0.364, which feels a little funny, right, to be dividing by a small number, but I get x equals 41.2. And looking at my picture, usually these pictures are kind of drawn to scale. If they aren't, you can shake your fists at your textbook. That makes sense. I would expect a number that's greater than 15, and I did get a number that's greater than 15. So there we go. If you have learned the fish method of solving proportions, that's going to be helpful for you here too. If I had 0.364 over 1 equals 15 over x, you might have learned this at some point, like 6th or 7th grade, where you can start above the variable, take the number that's above the variable and draw a fish. 15 times 1 divided by 0.364. That would be a quick way for you to get that x equals 41.2. You're welcome to do that to solve that proportion. All right. Hopefully that gives some clarity to this solving for missing sides using SOH. I welcome your feedback in the comments if you have anything to say about it. Thanks for watching.